Throughout this chapter, as we work with these fractional or rational expressions, I'm going to be reminding you of the things we know about fractions, just good old fractions made of numbers, and how they work. Because we're going to apply that to these rational expressions. So one thing we know about good old numerical fractions is that you are allowed to divide the numerator and the denominator both by the same thing, as long as that thing isn't 0. And a fraction is in lowest terms if you can't do that anymore, if the numerator and denominator don't have any common factors that you can divide them both by. So if it's not in lowest terms, we usually want to get it into lowest terms by dividing the numerator and denominator both by the same factor. So for example, well, to reduce to lowest terms, here's our strategy. Factor the numerator and the denominator, and then cancel, which really involves dividing out, any common factors that appear in both the numerator and the denominator. So let's start with an example that just involves numbers. 8/16. The fraction 8 over 16. We can divide the numerator and the denominator both by the same thing. The biggest thing they're both divisible by is 8. So if I do that, 8 divided by 8 on top gives me 1. 16 divided by 8 on the bottom gives me 2. And so 8/16 is equivalent to just 1/2. They're really just the same number. They have the same value. Now, another way of looking at what was going on here, instead of writing it actually in terms of division with the divided by sign, we can think, okay, 8 is equal to 1 times 8. We can factor it like that. And 16 is equal to 2 times 8. So they both have that common factor of 8. They're both 8 times something else. And if we cancel out the 8's, which is really just dividing by 8. When you cancel out a factor, you divide it away so it's not there anymore. Then what remains after we cancel those common factors is 1 over 2, 1/2. So this is the strategy that we're going to use when we're dealing with rational expressions. We're going to factor the numerator and the denominator, and then we're going to look and see if there are any common factors that we can cancel out. Now, what about this? 14x minus 73 over 14x minus 73. I notice that the numerator and denominator are the exact same expression. So we can take whatever's on top, divide by that exact same thing on the bottom, and what's the result of doing that? Any number divided by its very own self leaves you with 1. So we can simplify that expression down to just plain old 1. How about this one? Y plus 38 over 38 plus y. Do we have the same thing on top and on the bottom here? Well, yeah, we really pretty much do. With addition, the order doesn't matter. So 38 plus y really is the same thing as y plus 38. And then y plus 38 divided by y plus 38 is just 1. What about this? X minus 400 over 400 minus x. Are those the same thing? Well, not quite. With subtraction, the order does matter. If we switch the order, it's not really the same thing anymore, but here's what we can do. We can take one of these and factor out a -1. -1 times x minus 400. You'd have your -1 times x, that's your negative x. And you'd have your -1 times your negative 400, so that gives you your positive 400. And now we do have a common factor, the x minus 400, that we can cancel out. And what's left is just a 1 over a -1, or -1. So You can cancel when you have two factors that are the same except that the subtraction's in the opposite order, but when you do, you're left with a factor of -1. Useful to keep in mind. Okay, how about this one? 6x minus 30 over x squared minus 5x. So my strategy here is first factor the numerator and the denominator. So the numerator, do you see a common factor here I can pull out? Well, the greatest common factor on top would be 6. And what about the bottom? The greatest common factor there I can pull out is x. So the top factors into 6 times x minus 5. The bottom factors into x times x minus 5. And do you see what we can cancel? The x minus 5s. So after we get those out of the way, we have simplified to 6 over x. How about this one? 2a plus 14 over 2a minus 4. Same strategy. Start by factoring the numerator and the denominator if we can. So in the numerator, looks like I can pull out a 2. And in the denominator, there's also a common factor of 2. So when I factor those out, we get 2 times a plus 7 over 2 times a minus 2. What cancels? What can I divide out or cancel out here? The 2's. So what's left is a plus 7 over a minus 2. Can I do anything more? Can I cancel anything else? No. If you were thinking about canceling those a's, we can't do that because the a's are not factors. It's not a times something else. So we wouldn't be dividing by a if we tried to cancel those. So we can only cancel common factors where the numerator and denominator are both that thing times something else. So this is in lowest terms. Our final answer is a plus 7 over a minus 2. What about this one? X minus 9 over x squared minus 81. See anything we can factor here? Well, the x minus 9, there's nothing to factor there. But the x squared minus 81, that's a difference of two squares. That's one of those special factoring patterns that you need to be on the lookout for. These are both perfect squares. This is x squared and this is 9 squared. So it factors into x plus 9 times x minus 9. So do you see any factors that appear in the numerator and the denominator? X minus 9. So we cancel those. And what's left? Well, on the bottom, there's an x plus 9 left in the denominator. And on top, well, it doesn't look like there's anything left. But when you divide by everything that's there, we had x minus 9, we divided that by the whole x minus 9 thing. What's left? What do you end up with when you start with something and you divide by that very same thing? 1. So if we canceled all the factors, there's a 1 left over on top over the x plus 9 on the bottom. So the final answer in lowest terms is 1 over x plus 9. Okay, this looks familiar. It looks like the same thing we just did, except with one little twist. Now instead of x squared minus 81 on the bottom, we got 81 minus x squared. But when I factor, I got x minus 9 over 9 plus x times 9 minus x. We've got something that's not quite the same, an x minus 9 on top and a 9 minus x on the bottom. But remember, when you have the subtraction in the opposite order, you can cancel, but you have a factor of -1 left over. X minus 9 would be equivalent to -1 times 9 minus x. And then we could cancel the 9 minus x's, and we would have -1 over 9 plus x as our final answer. And instead of writing 9 plus x, if you wanted to write it as x plus 9, you could, because with addition, the order doesn't matter. So the final answer in lowest terms, -1 over 9 plus x, or equivalently, you could write it as -1 over x plus 9. Okay, how about this one? X squared minus 3x minus 10 over x squared plus 5x plus 6. First thing we want to do is factor. Factor the numerator, factor the denominator. We just had that whole chapter on factoring, so by now you should be good enough that you can see how to do that. So I'm going to tell you what the factors are. If you want to figure them out for yourself and you don't see them right away, pause the video, see if you can see what they are. Okay, I'm going to show you the factors. This numerator factors into x minus 5 times x plus 2. Notice if we FOIL that out, this is what we get. And the denominator factors into x plus 2 times x plus 3. That's what you would have to multiply out to get x squared plus 5x plus 6. So now that we have everything factored, do you see any common factors that we can cancel? The x plus 2's on top and on the bottom. We can divide those out, and we are left with x minus 5 over x plus 3. So that would be our answer, reduced to lowest terms. And what about this one? W plus 13 over 2w plus 13. Is there anything we can factor? Well, no. No, there's not. Is there anything we can cancel? No. Not legally, not and have it still be equal to this. We can't cancel the w's or the 13's because neither one of those is a factor. It's not that thing times something else making up the numerator and the denominator. So there's nothing we can cancel, and this cannot be simplified. It's already in lowest terms. It's as simplified as it's going to get.